Okay, I think we're ready. Yeah. Okay, let's do it. Okay, so Ishan for now, Ishan Savik, you guys can head off for now, and then I will share screen. Share screen. And do screen two. Share audio. Share. Okay, so my screen is up. Hello, everyone. How are you guys doing this week? So, yeah. So, hello, everyone. I hope you guys are all doing well. Thank you, Coderina, for hosting us again and for this opportunity. If you don't remember me, or if you were not here last week, I'm Kenneth, and so this week we begin our workshops hosted by High School Robotics team. So let's actually begin. Today we'll be filling up the entire 1 hour, so maybe we might have a slight delay, like not delay, but we'll extend our time. We have a lot of content to cover. So, but let's first off start with um, something that you guys are all really interested in is actually, yeah, no, actually, let's start off with the cart design video. We want everyone to be here at the same time. We're talking today about design. So design is obviously a really step-by-step step-by-step procedure, and we want everyone to be here. So I'm gonna play this video about cart design. Let me actually change my screen here. Sorry. Stop screen. Share screen. Share. Share. Okay. Okay. Tell me if you guys can't hear this. Sorry. Yeah, okay. Oh, you guys can't hear anything? Okay. Sorry about this. Stop sharing. Give me one more chance at this. Sure.
We went to IDEO, one company's secret weapon for
Can you hear
innovation.
anything? Okay, let me have time.
We went to IDEO, the product design folk, and said, take something old and familiar, like, say, the shopping cart, and completely redesign it for us in just 5 days. News correspondent Jack Smith tells us what happened next.
9 in the morning, day one, and these people have a deadline to meet.
So, welcome to the kickoff of the shopping cart project.
This is Palo Alto, California, in the heart of Silicon Valley, and these are designers at IDEO, probably the most influential product development firm in the world. IDEO has designed everything from high-tech medical equipment to the 25-foot mechanical whale in the movie Free Willy and the first computer mouse for Apple. Smith ski goggles, Nike sunglasses, NEC computer screens, hundreds of products we take for granted.
The point is that we're not actually experts at any given area. We're kind of experts on the process of how you design stuff. So we don't care if you give us a toothbrush, a toothpaste tube, a tractor, a space shuttle, a chair. It's all the same to us. We want to figure out how to innovate by using our process, applying it.
Project leader is Peter Skillman, a 35-year-old Stanford engineer. Project leader because he's good with groups, not because of seniority. He's only been at IDEO for 6 years. The rest of the team is eclectic, but that's typical here. Whitney Mortimer, Harvard MBA. Peter Coughlin, linguist. Tom Kelly, Dave's brother, marketing expert. Jane Fulton-Suri, psychologist. Alex Kazaks, 26, a biology major, who's turned down medical school 3 times because he's having too much fun at IDEO. Safety emerges early as an important issue.
22,000 child injuries a year, and so they're hospitalized injuries. I mean, there are many others.
And theft. It turns out a lot of carts are stolen. As the team works, it becomes clear there are no titles here, no permanent assignments.
And the other side gives us a lot of help, says, be safe. I'll give you a big red ball on a post, and that says you're a big guy. If you got a ball, you're a senior vice president. Or the desk, the red ball, it's all the same. In a very innovative culture, you can't have a kind of hierarchy of here's the boss and the next person down, the next person down, the next person down, because it's impossible that the boss is the one who's had the insightful experience with shopping carts. It's just not possible.
The team splits into groups to find out firsthand what the people who use, make, and repair shopping carts really think.
Okay, go.
The problem with the plastic cart is the wind catches it. Yeah. And these things have been clocked at 35 across the parking lot.
Oh, man,
That's actually a pretty good point.
The trick is to find these real experts, and so that you can learn much more quickly than you could by just kind of doing it the normal way and trying to learn about it yourself.
from everything I read, these things aren't that safe either, So probably the seat itself is going to have to be redesigned.
One of the interesting things for me is looking at how people really don't like to let go of the cart, except for the professional shopper, whose strategy is to leave the cart at various places.
3:30 in the afternoon, and the group is back at IDEO. There is no let-up.
Each team is going to demonstrate and communicate and share everything that they've learned today.
A shopping cart has been clocked at 35 miles an hour traveling through a parking lot in the wind.
We were in the store, 2 hours, and it was truly frightening just to see the kind of stuff going on.
You ought to designate some people to make damn sure that the store owner's point of view is represented.
After 9 straight hours, the team is tired. They call it a day.
So,
everybody cool?
Well, that's great. Thanks a lot. We had a great time today. Yeah.
IDEO's mantra for innovation is written everywhere. One conversation at a time. Stay focused. Encourage wild ideas. Defer judgment. Build on the ideas of others.
That's the hardest thing for people to do, is to restrain themselves from criticizing an idea. So if anybody starts to nail an idea, they get the bell.
The ideas pour out and are posted on the walls.
Oh, the blind, the privacy blind. Like when you're buying 6 cases of condoms, no one sees. If it doesn't nest, we don't have a solution.
Organized chaos. It's not organized. What it is it's focused chaos.
Vote with your Post-it, not with an idea that's cool, but with an idea that's cool and buildable. If it's too far out there and it can't be built in a day, then I don't think we should vote on it. Enlightened trial and error succeeds over the planning of lone genius.
Enlightened trial and error succeeds over the planning of the lone genius. If anything sums up IDEO's approach, that is it. Worried that the team is drifting, what can only be called a group of self-appointed adults under Dave Kelly holds an informal side session.
4 or 5 teams. 4 or 5 teams, and we give each team a need area. It becomes very autocratic for a very short period of time in defining what things people are going to work on.
If you don't work under time constraints, you could never get anything done, because it's a messy process and go on forever.
Back at the shop, it is 6 o'clock. The 4 mock-ups are ready for showing.
Baskets also can be, if you think you will have more volume, baskets can be put in.
A modular shopping cart you pile hand baskets onto. A high-tech cart that gets you through the traffic jam at checkout.
That you could mount a scanner on the shopping cart so that you, as the customer, as you pull it off the shelf, would scan each item.
one that's built around child safety, and another that lets shoppers talk to the supermarket staff remotely.
Yeah, where can I find a yogurt?
But the adults, again, decide more work needs to be done before the mock-ups can be combined into one last prototype.
Why don't we have all the carts come up here for a second?
I think you take a piece of each one of these ideas and kind of back it off a little bit and then put it in the design.
The design is still not there, but there's another motto at IDEO: fail often in order to succeed sooner. And some of the team will be up half the night trying to put together a design that finally does work.
Good. There it is! There it is! So we took the best elements out of each prototype.
The cart, which is designed to cost about the same as today's carts, is different in every other way.
What do you think?
Well, I'm very proud of the team. I think it's great.
Does this work for you?
Works for me great. Yeah. It's also beautiful.
The cart's wheels turn 90 degrees so it can move sideways. No more lifting up the rear in a tight spot. And you shop in a totally different way. The bags are hung on hooks on the cart's frame. Remember, there is no basket here.
At first, I was a little shocked, but I think you have some fantastic ideas here. It needs a little refining, but I think that it's great. I mean, we would want them.
She also gave us some really good comments about how we can make this thing better.
A lot of hours. Also, an open mind, a boss who demands fresh ideas be quirky and clash with his, a belief that chaos can be constructive, and teamwork, a great deal of teamwork. And these are the recipe for how innovation takes place. This is Jack Smith for Nightline in Palo Alto, California.
So, if you saw this video, am I still muted? Okay, so if you saw this video, we had IDEO. IDEO is a very large design company. So if they saw, they designed Apple's first mouse. They talked about the microwave. They designed, in this video, they were designing a shopping cart in 5 days. So they went through the entire design step-by-step process of how it's done. And you saw they drew pictures, they did sticky notes, they talked to experts. See, if you guys are doing FLL, you guys talked to experts, right? You guys wrote design plans. So today we want to go over, next week we will talk a lot about next week we'll be talking about FL, strictly FL, talking about FL judging, talking about FL. We'll have two FL judge advisors from Texas and Los Angeles. So they'll be coming here to talk about advice, what FL is, tell you all the secrets about FL judging, especially if you're competing in the United States, in Houston, or if you're competing even locally in Nigeria, India, Ghana, wherever you guys are. Okay, so that's next week. And the week after, we have another FRC team that will be talking about robotics, about motors, about simple machines, basic designs, basic engineering. So we'll have that. We're planning for that. So, but before we do that, what is design? So design is really interesting. So relating to, give me a second. Switch. I'm just trying to switch my screen. Okay, so this week, in our robotics class, we'll talk about design. So design is the process of how engineers think of new ideas and actually make it happen. And to relate, because you guys last week were asking me about the SpaceX launch, So using the SpaceX launch, we saw 2 astronauts launch into space using the Dragon and Falcon rocket. So how does this relate to design? Take a look at these engines here. So if you see, these are the engine. Let's just use the engines as an example. Obviously, the entire rocket is really complicated, and we have to there's many things about the design, but let's look at the engine. So this is the engine. Why do we use this type of nozzle on the left, if you see? So these are diverging, converging nozzles. I won't go into design, but if you think about it, SpaceX had to have a way of designing these nozzles. Look at these 2 rockets. These were the rockets landing. So if you, I don't, yeah, the video is not going to work. I don't want to mess with it. So these are rockets landing, and look at this picture is from last week of the rocket launching into the sky, and you can actually look up. There's a lot of stuff about rocket nozzles that allow it to. It's really, really cool. But I don't want to waste time off of the FRC team. So if you guys are really interested, reach out to me, talk to me. I'm an aerospace engineer, so talk to me, watch the YouTube video about last week's launch and tell me about, we'll have a Google Classroom set up. So talk to me about keywords that have in a video like max Q or SECO, okay? So I don't want to waste any more of their time. So let me quickly go into this. So this week we have our first high school robotics team from Los Angeles, Walnut, California. And if you see, this is their robot from last year and from actually this year, but unfortunately due to COVID-19, their season was canceled. They're a special team. This is their robot. If you look how cool it is. Obviously the design process was used, and one cool fact, 2 of their presenters, Harris and Ishan, even after the competition season was canceled, they took all their time and started printing PPE face shields. So you'll get to meet them later in a few seconds, but I want to give them a recognition for that. Let's go on, move on to the next slide. Okay.
So hello everyone, my name is Tara and I'm one of the presenters today, and all of the presenters today are from FRC, which is First Robotics Competition Team number 5857. We're located in Walnut in California in the United States, and today we're very excited to teach you about the basics of engineering design. Next slide. Harris, you're muted.
Hello, my name is Harris. Thank you, Tara. I didn't realize. So for today, I'm going to be talking about the basics. What is exactly design and what is the design process? So in robotics, it's a process used to create solutions to problems. As humans, we deal with a lot of problems, whether they're small, like dual pencils, or big ones, like how to keep warm when it gets cold. So naturally, we use the design process to come up with solutions and to our problems to make our lives easier. To solve dual pencils, we came out with pencil sharpeners. And to keep warm, we've learned to weave blankets. But we didn't stop there. We have a systemic approach, considering our criteria and constraints to improve these solutions, upgrading from blankets to heaters. Even though air conditioning might be a lot more complicated than just a pencil sharpener, all these products were created using the 12 steps of the design process, which will be shown later. The ITEA Standard for Technology Literacy sums up the design with the quote, "A design process is a systemic problem-solving strategy with criteria and constraints used to develop many possible solutions to solve or satisfy human needs or wants and to narrow down the possible solution to one final choice." Next slide, thank you. Okay, so this is the design process. The design process of making machinery or a piece of machinery always involves challenges that the product has to face, paired with goals it has to accomplish. When designing anything, no matter how complicated, keep in mind and refer back to this process as shown. Because as overwhelming as it looks, we're here to break it down for you and explain each step. I'll go over the steps first. The first step is to define the problem. The second step is to brainstorm. The third step is to research and generate ideas. The fourth step is to identify criteria and constraints. The fifth step is to explore possibilities. The sixth step is to select an approach. The 7th step is to develop a design proposal. The 8th is to model or prototype. The 9th is to test and evaluate. The 10th is to refine. The 11th is to create or make. And the 12th and final step is to communicate results. Next slide, please. Thank you. Okay, so we're going to help you understand the design process better. And today we have come up with an imaginary scenario in which a person has to create something just to save his life. As he tries to come up with a solution, we will explain how he uses this design process to make this mechanism. Be prepared to brainstorm, challenge yourself, and think creatively. Next slide. Thank you. The problem we need to solve regards this man stuck on an island because his boat got hit by a storm. Everything he brought with him on the boat is now destroyed. Next slide. So today, our challenge is for him to go back with a flotation device. And with everyone's help, we'll find the best possible solution. Thank you.
Okay, so as the man finds himself in this very horrifying situation, he begins by wandering the island to try to see what materials there are to try to help him come up with his solution. So because it's an island, as he wanders around, he sees rocks, coconut trees, sand, large leaves, lots of wood from lots of different types of trees, and he's very excited to find this special and very helpful material chest left by the last people who were abandoned on the island. Next slide. Okay, so he's very intrigued by the chest, obviously, so he opens it, and he's very happy to find a book about boats, a small motor with a propeller, a battery, aluminum metal, some rope, a mallet, which is kind of like a hammer, an axe, which is used for cutting down trees, a spud, which is used for removing the bark from trees, and some waterproof glue. Next slide. Okay, so now that he has all his materials, he's ready to begin the design process, which starts with defining the problem. Next slide, please. Okay, but before he can define the problem or figure out exactly what his solution needs to fix or accomplish, he first needs to identify the problem, or basically figure out what the heck is going on. So this starts by doing some research about the situation you're in, as the man did by wandering around the island. And now that you've done this research, you can start to think about possible solutions, in which process you begin to identify constraints or limitations that basically hinder your freedom in coming up with your mechanism. After this, you should come up with a design brief, which is basically a document which lists important things like timing or your budget. And all of these are very helpful on deciding on the best solution. But during this process, you should ask yourself questions like, what situation am I in? Where am I? What problems do I need to solve? And what are some possible solutions? And although these questions are very basic, they're very essential in putting you into the right path when you go to your next step, which is defining the problem. Next slide. Okay, so now that you've identified the problem or figured out kind of where you are and what's going on, you need to define the problem. And here we have a lot of problems. The island is small, there's no food except coconuts. He can only survive for 5 days because there's such limited food. And the man is also limited to basic materials, and he needs to get 15 kilometers away to his home. Next slide.
All right, so I'm Savik. I'm very excited to be here, and I'll be continuing this presentation on the design process. So Tara went through step 0 and step 1, and now that we know the problem that we're trying to solve, we can start brainstorming ideas on possible solutions. And so what brainstorming is whatever ideas you possibly get in your head when you're brainstorming, you write down. It doesn't matter if the idea seems unreasonable or if it doesn't sound right, you should still write it down. So brainstorming sessions are a period of time where you just spend time thinking about any solution with your current knowledge about this problem. And so this slide shows a couple of ways people brainstorm, such as putting sticky notes on a wall or mapping out a bunch of designs. You can see that there's that all they do is they take every single idea that comes inside their head and just record it. Next slide. Okay, Kenneth.
Okay, so guys, I want you guys to go in the chat right now, and I want you guys to tell me about what are some ideas that you have. What can he do? What can he make? What can this guy make? Remember, this guy only has what does he have? We only have let's see, go back. We only have oopsies. Okay, so on the island we have rocks, we have coconut trees, sand, large leaves, wood, a materials chest, and inside the materials chest we have a book about boats, a propeller, a battery, some aluminum, some metals, some glue, a rope, mallet, axe, and spud. So tell me in the chat right now. I'm reading it right now. So what can he do to what are some ideas that you have? Brainstorm. Let's think about some ideas. What can he do to think of how to fix this problem? Okay, so if you guys want, draw a picture, draw what you want to do, draw your ideas. We'll have a Google Classroom, so and then you can post your ideas, and I'll come and look at some of your ideas later after this workshop. Yes, I see some really nice ideas, some like a motor boat, cutting out the wood and sticking it there. Yes, a boat. Yes, everyone's saying a boat. Yeah, so let's move on and let's have Savik continue this workshop.
Okay, so as I said in brainstorming, you take any ideas you possibly get and write them down, even ideas that don't make sense. So as you can see here, a couple of the ideas you could have thought of, and some of you have thought of, such as boats. You could have even said plane, because it doesn't have to be reasonable. This is a brainstorming session, and you just want any ideas. And we have ideas like submarines, canoes, sailboats, and it can even be ideas such as making a signal fire and trying to signal a passerby airplane or boat to save your life. So the reason why we don't just use reasonable ideas and we can write down any idea is in the next few steps, we're going to define criteria and certain goals. And then we can pick and choose from this list of ideas that we create, which ideas are the best. Next slide. Step 3 is to research and generate or specify ideas. So next slide, please. It's really important to research so that you can come up with a reasonable idea. For example, luckily this man has a book about boats with him, so he can research. But in order to make a good boat, we need to know certain concepts, such as buoyancy, density, and aerodynamics. Buoyancy is the ability to float in water, and this depends on the mass of the boat and the density of the boat, and compared with the density of the water. And density is how compact a certain material is, how much of its mass is compacted into a certain amount of volume. And aerodynamics is the ability to reduce drag or air resistance or whatever you want to call it. Basically, it makes the boat easier to pass through air and water. Next slide. Okay, so step 4, we need to identify our constraints and our limits. Obviously, we don't have unlimited time. He only has 5 days to live on just coconuts. We have constraints such as materials. We don't have all the materials in the world. We only have certain materials from the material chest or wood. These are all constraints that we have to consider when we choose our final solution. So, constraints that we have is that we only have 5 days worth of food, limited time, materials, tools that I said. And that means we have to build the boat as quickly as possible. And the boat needs to travel 15 kilometers without sinking. So we have to keep these ideas in mind when we select a solution to our problem. Next slide. Okay, once we know our criteria, we can start to explore possibilities for solutions. This is where we get more specific. From the brainstorming session, we just wrote down any ideas that came to mind. Now we have constraints and restrictions, so we can start eliminating possibilities that don't sound right or we can't do. Okay, so Kenneth, this is your slide.
Okay, so the next slide is one of the most important, is exploring all possibilities. So as an engineer, we want to think about the pluses and minuses of each idea. So for example, let me move on. We will use a decision matrix, so is on this slide. So what is a decision matrix? A decision matrix basically takes all your ideas. So for example, some of you guys in chat, I can see right now are saying, how about a boat? A motorized boat. Yes, and you guys are proposing really good ideas to on how to solve this problem. For example, idea 1 might be a boat, a motorized boat. An idea 2 might be just a boat you hand paddle or a raft. Idea 3 might be a plane. Idea 4 might be another idea. So each column, as you can see in this decision matrix, has its own part to it. For example, we have complexity. So if is the idea complicated? For example, 4 is great, so it's not really complicated. Development time, does it take a long time to develop? So that one is 1. So 1 is not good. It takes too long to develop. Cost. Okay, for example, if I was Boeing, if I was making airplanes, how much does it take to make this airplane? Will it be too expensive for me? Can I sell this plane? Function. Can this plane work? Can this plane fly from Africa to the United States? Okay, so how well does it function? Okay, float. In our situation, float. So we also, sorry. Okay, so float. Yes or no? So if you look on the bottom, if you look at the chart, it says 1 from 1 to 4. So 4 is great, 3 is good, 2 is okay, 1 is worse. So, but we also think about using yes or no. So if it's yes, we put a 1. If it's no, sorry, we put a 2 actually. I made this wrong. So ignore that. Ignore that really quickly. So 2 is yes and 1 is no. So then we add up all the points, okay? So we're adding up all the points. Pretend I'm using 1 and 0. So we have 8, 6, 10, and 8. So here, with this, we pick our idea. We can see, we can narrow down idea 3 is a pretty good idea. So let's look at more into idea 3. Okay, let me see. So now I'm going to give it back to Ishan, who's going to talk to you more about how about selecting an approach.
Actually, it's me, not Ishan. Ishan will be later. But now that Kenneth talked to you guys about this in decision matrices and how to single out ideas, we have some reasonable ideas here that we can start to single out. I see many of you are talking about a motorboat or a sailboat or a canoe with oars. Those are all very reasonable ideas. Some of you said raft too. Now we need to select one that would be the most reasonable. And we decided on a few constraints in step 4. And now we can use those constraints to single out which idea might be the best. So you can see here we have constraints such as, do we have the materials to make it? Do we have enough time to make it? And is it safe for traveling 15 kilometers? And out of these 3 options, the one that is easiest to make in a certain amount of time, but is also very safe, is a canoe, because it's made out of wood, and we have wood, and a sailboat might take too long to make, and we might not have the materials for the sailboat, such as the sail, and a raft can easily flip over during travel, so it's not as safe as we want it to be. Next slide. Okay. And we also need to decide on a boat design. Boat design is really important because the more streamlined it is and the more aerodynamic a boat is, the less time it will take to travel through air and water. And we also need to decide on a material that we can use for this boat. We have metal from the material chest, but we also have wood. And we have to decide which one would be the best to use to make this boat. Okay, and here are the examples that we offered in a real picture. That is a canoe with oars, or we can even have a canoe with a motor propeller. And you can see in the real world, we would use CAD software, as you can see in the top right, to design things before we actually make them, so that we can reduce the error. And so now, Kenneth, you want to take them into a session?
So right now, I want you guys. So I see some of you guys say yes. You're telling me about different ideas. Keep on telling me. So this is kind of a session. I want you guys. I'm reading the chat right now to tell me what material is best. What we have some metals on the island. We have some aluminum. We do have a lot of wood. We have coconut trees. How about a motor? Do we have gas or do we have battery? Can we power the motor with? Can we power the propeller, the boater, with a battery? Will we have enough battery? Those are questions we need to ask. So if you look at the top right picture, that is our CAD software. So that is, I think, is that just a simulation? I think that's just a simulation. It's not the actual CAD. So you can see about when in the real world, when we're not stuck on an island, we have computers, we have everything. We want to design. We want to take a look when we're selecting our approach. We want to take a look at the CAD. Look at what stress, what forces will be acted on the boat. Will the boat sink? Will the boat float? Would our boat snap in half? Will our boat leak? We want to use. We live in the 21st century, so we can use a lot of these softwares to design our boat. On the left, we have another picture of it's a rough sketch of a canoe. Okay, so tell me, look at the chat. I want to see. Yes, we have a lot of wood. So but my next question is, we have a battery, but can our battery bring us all the way home? We have a propeller, but can we bring us all the way home? How do we mount I want you to ask yourself, how do we mount the motor to the boat? Can we do that on an island when there's nothing there? How do we steer the boat? How do we if we have a sail, how do we steer it? How to steer it? Sorry, how do we steer the boat? We have to think of all these different types of questions. Okay, so like right now, yeah, comment more. I want to hear more activity. Last week, everyone was really involved. I want to see more. I want to hear more of your ideas. So comment your choices. Tell me about what do you think we need to consider? We need to consider, yes, someone said density. Yes, we need to consider how full is the battery. Usually, if you have AA batteries and you leave them at home for a long time, they might not be as good, right? So yes, yes, hydropower. What if we consider all these? Speedboat. Yes, is it easy to make a boat out of wood? How hard is it? Can we carve the boat? Okay, yeah. So tell me what you guys think in the chat. Okay, so back to Savik.
Did we already pass the ore slide?
Oh no, it's later.
Okay. Yeah. So many of you guys are really good at thinking through this stuff. A lot of you are talking about the propellers and the oars already, and how a boat should be wood instead of metal because metal would sink. Those are all really good observations. Wood, as I said before, this is why we needed to research about buoyancy and density. Wood is less dense than metal and therefore has less mass than metal. And mass is what's important in determining buoyancy. And wood has less mass and can float better than metal. And for boat shape, As you can see, the best boat shape would be one with a streamlined tip so that it passes through air and water more aerodynamically. Next slide. And then you guys already moved on to this step, but we have to decide oars and propellers. And I'm reading the chat right now. You're right. Metal will not necessarily sink. That's right. But wood would be better in terms of staying buoyant and floating. And it's also very hard to make a boat out of metal and carved metal. So for our method of transportation, we need something to move the boat, either oars or propellers. And we have a battery-powered propeller from our material chest. And we also can make oars from wood from all the wood that we have. And we have to decide which one is worth spending our time in making. And from our criteria from step 4, can it travel 15 kilometers? Is it fast enough, decently fast enough? And is it easy to make, attach, and use? And oars are easier to make, which is why, and easier to incorporate with your boat, which is why it's a better choice than propeller. And many of you actually made the observation that a battery-powered propeller has the chance of running out of battery during the trip, and that would leave the man in a very bad spot, stranded in the middle of the ocean. And so we want to take into consideration all those possible errors right now when we're considering an approach. Okay, next slide. Okay, so step 7 is starting to develop a design proposal. So you want to set your steps on how you're going to take in this case, you want to set your steps on how you're going to make the boat. It's important to decide these steps ahead of time and not decide the steps while you're making the boat to prevent error. You don't want to have to constantly keep remaking the boat over and over again because you forgot a step in the way, or you didn't think about what is the best part of the boat to start with. You want to think of all of these things before you start building your boat. And so this is what the developing the design process step is. Next slide. And so we want to make a detailed solution. And in the real world, we could do this with CAD software. We could do this with a series of really intricate drawings and prototyping and making sure all the steps to how you're making this boat are reasonable. So next slide, please. An example of a design proposal. This is a really short one, but to make it clear how a design proposal should be, you can see how this drawing here, this is how we would draw this boat in the real world where we're not stuck on an island. So we can have every angle and see what our goal is, as well as have steps on the side so that we have a procedure to follow, and so we can limit our errors. So in this case, or can you go back? In this case, we just have a example design proposal where you can see the first step, make the hull, attach 2 pieces together with rope. And so it gets really detailed, and that's what you want in a design proposal, so that you're doing all the thinking ahead of time, so that you're not thinking about what you should be doing next while you're building the boat, and you've already thought through it ahead of time.
So to build up on Safik's idea, so design proposal, obviously when you're working for a large company, you want to have this really established. So design proposal is basically, on this island, we don't really have an idea. Maybe we can draw it out on a leaf if we have a leaf. Yeah, we have a leaf. Do we have a pen? Yeah, so we have to think about this. Do we have a pen? Now, a design proposal, going back to this. So in a large company, you want to do it out in CAD, so AutoCAD. That's one of many companies use this now, and before too. But AutoCAD. So I don't think this is AutoCAD. This might be. I don't see the CAD software, but basically you want to have your, you want to use CAD. You want to create your model in 3D in your computer on your computer. So if you guys can see, this is SolidWorks, and I just took this picture from their website. Look at this, how detailed everything is on this CAD file. Look, you can take a look, even everything from the screws to all the single small parts, the chains, the sprockets, and so that's the detail you want to get to when you're doing your when you're making your CAD files. And on the left, if you can see, it's kind of blurry, but it's our engineering notebook. It's our technical drawings. We want to draw really detailed drawings. If you want to learn more about, I don't think we have enough time during the summer to learn about each step and the procedure to drawing this, but this is actually one of the most important stuff, because we are, as engineers, we come up with ideas, but other engineers will also come up with the same ideas. And we want to say, these ideas are ours, and we want to document, we want to, and if you participate in FIRST Robotics, the competition, you know about how important documentation is, okay? Yes, so you guys are asking me several questions. I'll look at the questions later. So if you look at this slide, look at this documentation. So if you look on here, it says confidential, right? On the top of the screen here, it says confidential. It has a lot of data, has a lot of information. We can see on the right picture, we have a lot of pictures. We post pictures inside. We label. We do a lot of different stuff. So this is your design proposal. When you're an engineer, you want to have the good amount of detail in your documentation. Okay, so we're good. So if you want to learn more about documentation, reach out to me.
And I actually saw someone in the chat call this design proposal a blueprint, and that's a good word to use. It's a blueprint of what you're about to do. And as I said before, it's useful in preventing possible errors that will set you back. And so now step 8 of our process, Ishan will take you through.
Okay, hi, my name's Ishan, and I'll talk about step 8. So step 8 is modeling and prototyping your design. So in the case of the person on the island, he would want to maybe prototype with different types of wood. He wants to make sure there are multiple prototypes which he can test on. Next slide.
Okay, so let me go over this slide actually. So when you're creating, step 8 is model or prototype. If you see, this is so if you can see, there's a plane here. This is a wind tunnel. So as we talk about aerodynamics, right? We have to talk about how well is this. Give me a second. No. If laser pointing. So look at this car. You can see the air that's flowing through, flowing over the car. So a boundary layer is formed. You don't have to worry about any of this, but we want to create. We're probably on a boat, so I don't know. I mean, on an island, so I don't know how much prototyping or making of model that you can actually do when you're starving and you don't have anything, and you want to get off the island by really quickly. So, but look at this. We want to always kind of create a model, because if you think about it, if we make a plane and then we make a full-size plane that we want to fly in the air, and we don't make a model, we just make a plane, what if it doesn't work? What if it just breaks down? What if it can't fly? What if it can't generate enough lift to get off the ground? What if it needs a longer runway? So we want to always test these. Same for the car. What if it can't travel fast enough? We always want to think of these. And so I just included a model of a boat. But if you're on an island, do we have enough? We have to think, do we have enough time to make a model of a boat? Okay. So when you're making robots, you always want to create a model. We want to create a prototype. Okay. So I think let me give it back to Ishan for the next slide.
Okay, so step 1 is testing and evaluating. So these are the two types of boat. One is made out of wooden planks, which is on the left, and one is made out of bark, which is on the right. So before you go and like pick your favorite boat to use, you need to test it. On the island, the person has made 2 boats, as you can see, and he has tested them. So now, after testing them, he knows that the boat made out of bark will float, while the boat made out of planks will sink into the ocean. Next slide. So even though you know you're going to use the boat made out of bark, you still need to know what went wrong with the prototype that failed. Analyzing your mistakes is extremely crucial in any design process. Now for the boat made out of planks, it seems that the wooden planks were too flimsy or bended too much when a person was in the boat, leading to a structurally unstable boat, or a boat that couldn't support any weight. Second, before the boat went down, there was a lot of water coming in the boat from the seams, or where 2 pieces of wood were joined together. In other words, some seams cause water to leak in. In technical terms, these seams are called failure points. Even though we covered up all the seams with glue, nothing is perfect, and sometimes mistakes will happen. Next one. So the testing and evaluating step is important in finding your strengths and weaknesses in your design. Learning from your mistakes is, as I said, an important step in creating a better product. From flaws and strengths in your prototypes, you should improve upon your design to make it the best version of itself. Next slide. So as you can see, testing is heavily focused in many industries. Many of you have seen the SpaceX launch a couple weeks ago, in which humans traveled for the first time on a SpaceX rocket. Now, human life is extremely fragile, and no companies want anything to happen to their astronauts. So extensive testing happens before anyone steps onto a rocket. On the left side, you can see a SpaceX booster in the testing phase. Obviously, it has failed, but SpaceX has learned from their mistakes and will create better boosters after this prototype. On the right, you can see the Crew Dragon on the very right, and then in the middle, you can see the Crew Dragon on top of the rocket. So the Crew Dragon is where the astronauts actually were. That's where the astronauts were in when they were on the rocket launch. Now, as I said, human life is extremely important. So SpaceX has done extensive testing on the Crew Dragon capsule to make sure they prepare for the worst case scenario. This is another slide of testing and evaluating. On the top left, you can see a phone case is being tested. You don't want your phone to break, but as you can see, sometimes phones break. But it will eventually lead to better phone cases. On the top right, you can see Boeing testing their wings. They don't want to have their wings break apart mid-flight, so they have to do extensive testing on their wings and make sure it's able to support the weight of all the humans and some extra weight just to be sure. On the bottom left, you can see a tensile strength test happening, so making sure a material has a certain amount of strength. And on the bottom right, you can see a car being crashed. Now, why would you crash a car? Well, you want to make sure it's safe, just in case of the worst case scenario. Next one. So step 10, refine. Next. So now that we've tested a useful design and a failed design, we need to combine the knowledge we gained from both designs to make the best design possible. The strength of the bark boat we want is that it is able to stay together and float. So we will use the same type of bark we used to make that boat. We already know we wouldn't be using wooden planks, but what about the seams that caused the leaks? Well, in the final design boat, we will try to have less seams, since more seams would lead to more failure points. And we would have less seams by collecting big pieces of bark instead of a bunch of little pieces of bark. And we won't bring as much of stuff into the boat. Remember, the seams on the wooden plank boat broke under our weight. So we weren't able to test how strong the seams were on the boat made out of bark. So we don't want to unnecessarily stress it out. So that means we would bring only essential material, such as food, glue, the oars, and maybe some bark. Exactly. So this picture summarizes the refine process. As you can see, it's a telescope, and it basically means the more you learn from your failures and about the topic through research, the better your results will be. So next one. So this is step 10, create or make. So now he knows exactly how to create the best boat. Now he actually has to do it. As you can see, step 1 is use the tree bark and rope to build the boat. Even though it seems simple, he has to do it. Step 2, count the bark and make sure you fill it with glue in all the seams and make sure it's perfect. And you can read through step 3 and step 4, which will complete creating the boat. And step 11, create and manufacture, with Ken will talk about.
So creating and manufacturing, if you sorry, my screen's a bit laggy. I don't know if you can see this. So if you look on the picture on the right, in the industry, you want to create your actual object now. So on the right is a CNC mill. So if you can see, it's like a drill, but if you but we cut out, it's like it's a mill basically. So we're cutting out. So you know how a 3D printer, it's an additive process. This one is a subtractive process. Okay. On the left, so you want to, on the left is just a picture of a workshop. So by this stage, you want to be starting to make your actual product. And on the top is a car manufacturing plant. I think that's a Toyota. Yeah. So, but anyways, on the background. So by this step, you want to create your object. Okay. So let me, next slide. Okay.
Okay, step 12. Now that you have made your final boat design, you have to communicate your results. So for the person on the island, he has to get to the mainland and then communicate his results. So next slide. As you can see, the person has reached land, and this is the final step in the design process. Well, now what should he do? Well, he should communicate his results. People need to know what he did. He should write a book, go online, talk about it, write a blog. He should spread the word. Talking about the challenges you faced and how you accomplished your goal is extremely important. This will help people not make the same design mistakes you will make. Taking your audience through the whole design process will help them understand the challenges you faced and how you got past them. In the real world, engineers and inventors go through most of the step before anyone even knows that they're doing this. Inventors don't try finding investors at early steps. Once they have accomplished their task or are nearly done accomplishing their task, they will find investors or companies that will buy and expand their products. People are eager to find solutions for certain challenges they are facing, and not sharing your product likely means that they will have to go through this whole process of spending time and money to usually get the same product as you do. So share your results. Make sure you get a patent. People try to steal your product design. And with the example we gave you, the design process stopped once that person reached the mainland. But the design process never really stops. You should always try to refine and optimize your design. There's always a better version of your product. And if you fail or stop in one of your steps, you should go back to step 1 and start again. And once you think your product is perfect or near perfect, you can sell out or you can expand your product.
So let me talk about this slide. So the iterative process. So if you think about this, is just another chart similar to ours. So for example, we want to ask every step. We want to ask, can we move on to the next step? For example, on the problem 1, it says define a problem. So is the problem valid? Is it justifiable? If it's not, we have to move back we have to say, what is our problem again? We have to define our problem again. Okay, so then step 2, generate our concepts. So does the for example, here they use, does the technology exist? So yes, no. If it doesn't, we have to go back and what's our problem again? Okay, so step 3, developing a solution. Is this a good solution? Can we use the solution? So if it doesn't, we have to go back to step 2 or step 1. So it's the same. It's the same one. The most important one might be, does this prototype or test work? So that's the almost important step. Can we succeed our test? Like if we put the boat on water, will the boat sink? Okay, and then after that, evaluate the solution. Will the solution work? If it doesn't, we have to go back to the first step. We have to keep going. This is an iterative process. This is what an iterative process. If it doesn't work in one step, let's go back. Okay, so after that, we can present our solution. Okay, so
So this is the whole design process. I'm just going to recap it really quickly. So first, you have to define a problem. In the case of the person, it was getting off the island. That person has to then brainstorm solutions, try to gather information to help his cause, identify goals and challenges, and explore possibilities of how he can get off. Then he has to finalize an approach. He has to develop a design proposal, a very precise design proposal. He has to model and prototype, test and evaluate, learn from his mistakes, and refine. And he has to finally create his final product and communicate his results. Slide.
Okay. So do any of you have any questions about the entire design process? About the boat is just an example. So let's see, how fast does a man have to work? Yeah, like 10 hours a day. If you want to, well, he's hungry, so he might want to work faster. Is there a way? Yes, there is a. So Anthony, there is a way you can shorten the steps. We do have. See if you see this flow chart. So we have this flow chart. We have this chart. We have different types of steps that we could do, and each flow chart is different. So different companies will have different requirements. So for example, if I want to make planes, maybe the requirements are larger. You don't want the plane to fall out of the sky, right? So you might have more steps. So maybe when you're actually designing a boat on the island, you might use less steps. But each different flowchart, they have industry standards that you can use. You can find online. You can search up design processes. Is there a way he can join the wood bars?
Wait, when it
yes.
comes to shortening the steps, as Ishan mentioned, that's one of the reasons why it's so important to communicate your results. Because if you know some of the flaws other people encountered, you probably wouldn't spend as much time modeling or prototyping.
And to address that question of a way he can join wood bars together, the most obvious one is obviously the waterproof glue that was in the material. I see someone mentioning it. But there are also plenty of other ideas, such as using the bark, or not the bark, the husk of coconut trees to make ropes and things like that. And that's why, like, I like this discussion you guys are having. You guys are going through so many different possibilities that we didn't have in this presentation, and different errors that we didn't account for in this example. And that's exactly how a design process group should be like. You should always be questioning each other, and you should also always be striving for the best solution.
So another one of the questions from Don is, I think the Google Classroom link. Those folks are gonna be sending out the link soon. So the next question, how long have I been working in robotics? So I've been working in robotics for about 9 years. Right now I am in aerospace. I'm attending aerospace engineering, so I'm going to be an aerospace engineer. I'm attending university. I'm in my final year. Some of the students here have been up to 4 years in high school. Maybe Ishan and Safik have been doing FLL too. So maybe for them up to 6 years. So My favorite bit is always, I'm a design person. I like to design things. Okay, so I like to plan everything out, and I want to make sure everything is working before I actually make it. I don't know if do you guys have, Ishan, Satvik, do you guys have a thing you like the most?
About robotics?
Yeah, what's your favorite bit about robotics?
Just the I like those moments where you have to think of something completely different than what you thought you had to think of in order to solve a problem. Like, how should I say? I can't think of an example right now, but where, like how you said, the design process, I like it when there's like a really hard problem and you just come up with you think of an ingenious solution to it that nobody would have thought of before. And to address this question of how did we come up with the design process, we didn't come up with it. It's hard set into the engineering field of this design process that every engineer follows to come up with the best possible solution.
Yeah, so building on Savik's response, so the engineering community has, if you, for example, if when the engineer needs to design something, we have steps, we have certain guidelines that we have to follow. Even though it is still our design, we are still following these designs. I mean these flow charts or this process. So let's see, what's the next question? Let's see. Did you actually think of being a robotic engineer at first? A little bit. When I was a kid, like probably your age, yeah, probably. I don't know if Ishan or Tara or if any of them have a response to this one.
Not really, but to address the next question, is the scientific process the same as the design process? A lot of the steps are very similar, like both begin with identifying the problem, both involve doing research, both involve conducting some sort of experiment. But the main difference is that during the scientific method or scientific process, you're trying to answer a question or test a hypothesis, such as, whether one thing works better than another at making a plant grow or something like that. That during the design process, you need to actually normally build something in order to solve a problem. So rather than answering a question, you're trying to come up with a mechanism or a process or some sort of solution. Yeah, instead of answering a question, you're trying to solve a problem during the design process.
Do I love math? When you get to my level of math, maybe not. But before that, yeah, sure. When you get to really hard math, maybe not. Yeah.
How to break down many possible solutions? That is what criteria and limitations are for. So just to reference this boat example, we had a time limit. He can't survive more than 5 days on just coconuts. And we also have a material limit. And so to narrow down all these possible solutions, you take your criteria or your limitations
Let me
and check.
let me actually answer that one. So
Okay.
so how do you pick out one idea? So as you remember, we had our decision matrix, right? Where we picked what we wanted to do. So like so how expensive it is. Is this easy to make? We want to add up those points and we want to decide between all these, which one has the most points. That's the easiest to make. After that, we can pick out which design is actually good. What are the benefits to each design? What are the flaws to each design? Will this design work? Yeah. Okay. So it's actually each part of each idea. We need to, if I'm an engineer at Boeing, or if I'm making a car, I need to make sure is this design reliable? Okay. So I don't want to take up too much of your time. So yeah. Yeah. So I think this is a good session. What level do you mean? No, I'm learning math harder than calculus. It's yeah. So I think we have to wrap up now. So unfortunately, I have to. Okay, yeah. So I think we're all good for this week. If you have more questions, I want you to you to ask. We will have a Google Classroom. So ask Google Classroom. Ask me. I will respond to you in Google. At the moment, you will, for most engineers, you will have to know about linear algebra and differential equations. So there's more to that, but I'll talk to you in Google Classroom if you want, and I will, if you're really interested about this, I'll share my ideas with you. Okay, yep, that's a wrap. Thank you so much for coming this week. Next week we'll have talk about FLL, and we'll have judges come, so really special. Make sure to come to that if you're in robotics. Yes, thank you so much. Yes. Okay, so see you guys next week. Thank you so much.
Bye.
Wait, Savik,